Everyone, welcome to this video on angles, and specifically we're going to be talking about trig functions of lots of angles, not just those between 0 and 90, but a whole bunch of other ones as well. We are going to focus only on degrees in this video. There'll be a later video, I'm sure, that deals with radians, but for this one we're going to stick with degrees. This activity is somewhat long, several pages, so we may break this up into two videos. We'll have to see. There's a few key terms that we'll go through first. One is just angle, right, which is the amount of rotation from an initial side to the terminal side. One is standard position, which is the initial side at 0 on the positive x-axis and moving counterclockwise toward the terminal side, which is wherever you're going to end your angle. And clockwise movement is going to count as negative, counterclockwise counts as positive. We'll talk about those other two in a second. So let's go ahead and start with that. So an angle at 0 degrees, if I go ahead and put that in, would be just right here on the positive x-axis, something like that. Not moving anywhere. Now, as soon as I start to travel away from that, I start to accumulate some space between the x-axis and what we call the terminal side. So if I were to go, I'm going to make this a little bit more narrow. If I were to go, say, from 0 to this terminal side right here, right, somewhere right in there, actually, let's make that a little darker, that a little smaller. Try that. Then that is going to be what we call 30 degrees. So a lot of times people put a little space right there in between, meaning that is my 30-degree angle. If I want to travel further than that, let's say to that 120, right, I would be moving from here all the way around through all these angles till I get to the 120, which is right over here. So this would be the terminal side, right, along that line, and the angle would just be formed by going from 0 all the way around to that 120. So we call that a 120-degree angle in standard position. Now you can keep the 120-degree angle and put it in all kinds of other positions, right? In triangles, sometimes we'll see 120-degree angles, but not in a standard position. But right now we're just talking about standard position stuff because it's going to be useful both now and later on when we get to the unit circle and radians and all kinds of stuff that are going to happen later. You can also go in the negative direction, right? So you'll notice on this circular spiral that's right here, all these purple ones are going positive direction from 0. About every 15 degrees you'll see these green lines kind of indicating 15 degrees. So I go 30, 60, 90, and the 15-degree marks in between, where I get a 15, a 45, a 75, and so on and so forth. You can also go in the negative direction. So if we go from 0 right this way, now we are moving clockwise instead of counterclockwise, and this is going to be a negative angle, right? So we can go ahead and try to count, right, how far is that and what angle would I want to put in there. So if we're going to count through, this would be, let's see, 90, right, to get down to this part right here. So getting to here is 90, and then we'll go another 15, another 30, and then another, we'll say 45 after that. So 90 plus 45 would be 135. So this right in here would be negative 135. So negative 135 degrees. Now you can fill in a whole lot of these other angles. There's a few ideas that we'll talk about here in a second, but we'll just go ahead and fill in a few of these as we go. So if I wanted to keep going in that negative direction, right, keep going all the way to this one right here. Right now we hit the negative 180 when we get right here, and then we go an extra 30, so I'd be at negative 210. So this would be negative 210 degrees. You can keep going, right? Another amount along that orange line, right? Still in the negative direction. So now this is going to be negative 270 once I get to that top, plus another 30, so that would be negative 300. So a lot of these angles we will count kind of going off the 90, 180, 270, 360, those kind of markers, and then adding or subtracting kind of from those. If we looked at some of the positive angles on the outside here, so say this one up here above the 90, that circle, that one would mean, I'm going to go ahead and change color a little bit here. Let's pick this tealy color. So that would mean going from 0, right, all the way around, right, we're going to go all the way around 360, and then another 90 right before I finally get up right there. So we've gone all the way around once, 360, plus another 90, and finally end up right there. So 360 plus 90, that would be 450. So we'd say this angle right here, 450 degrees, right, standard position. And you can fill in, even more of those if you want to fill in all the rest of the blanks, that's fine. But there's a few terms we'll go ahead and define now. They're up here. One of them is coterminal angles. So angles that have the same terminal side when they're in standard position. So we would say these two, right, 90 and 450, these are coterminal angles because they end in the same position, right, on the terminal side. So they both end on that positive y-axis right there. We would also say the 60 and the negative 300. Those two, this one and this one, they are coterminal angles because they are both along that same green line that goes through the negative 300 and the 60-degree angle. So any two that are along that same ray pointing from the origin out, those are what we call coterminal angles. And that's going to be important when we get to trig functions of angles. Trig functions of coterminal angles are actually going to be the same. So there's a lot of repeats that we're going to get with trig functions just because there's a lot of repeated positions that you get when you go through spinning around the origin. Reference angles, these are going to be the positive angle measurement between the x-axis and the terminal side of a standard position angle. So these reference angles, we'll leave those for a minute, come back to those, but basically this is just the positive amount of space between some terminal side and the x-axis. And we'll go ahead and investigate that a little bit here pretty soon. Let's go and answer a few questions first, and then we'll, like I said, we'll come back to that idea of reference angle. So number one, we're going to find two angles, a positive and a negative, that are coterminal with 310. So there's a few ways to do this. You can draw it out, right? So I could go and identify, all right, where's 310? 310 is going to be somewhere in here, and then try to figure out where to go from there. But really, coterminal angles, you should always be able to just add or subtract 360, right? Go all the way around, forward or backward, whichever way you want, and get back to that same terminal side. All right, so I'm going to take that 310 and I'm going to add 360, and that'll give me, what, 670. So there's my positive angle that'll be coterminal, and then I'll take 310 and subtract 360, and this will give me negative 50 degrees. And that'll be my negative angle that'll be coterminal with 310. So you can always just add or subtract 360 to get coterminal angles. Sometimes that'll be nice when we have very large angles. We can subtract 360 to get down to smaller ones, or if we have negative angles, we can always add 360 to get back up to positive ones. A lot of times we'll need to know kind of familiar spaces when we're dealing with the trig functions of these big or negative angles. A strategy, right, that you can use to find an angle that's coterminal with an angle you're given is exactly what I said, right? So I'm going to write it this way. We can take theta and then plus or minus, right, plus or minus 360 degrees. And that will be our coterminal angle after that. Reference angles is mentioned in this third one, so we'll go ahead and talk about that here in a second. An angle that has a reference angle of 30 degrees has a terminal side located 30 degrees away from the x-axis. We want to find three angles in each quadrant that have a reference angle of 30 degrees. All right, we're going to label them on this figure below here. So I'm going to come down here, we'll label those for number 3, and then I'll erase them, and we'll maybe look at some of the stuff from number 4. So an angle that has a reference angle of 30 degrees will, like I said, be located 30 degrees away from the x-axis. So that would be, if I were drawing them in, we'll go ahead and draw them in right here, right? This is 30 degrees away from the x-axis, right, if I were measuring this way. There's another one over here, right, which is 30 degrees away from the x-axis, right, right in there. There's going to be another one down here. And there's a lot of construction kind of going on in the background, so sorry if you can hear that in the background. There's another 30 degree angle right there. So these 4 places are where I'm looking. So what I'm going to do is say, all right, here's 0. So this side I would say is 30 degrees, right, if I were going just this way. If I were coming over here all the way halfway around, this would be 180. And then I'm going to back it off 30 degrees. So 180 minus 30 would be 150. There's another one down here, which would be 180 plus 30. So that's going to be 210 degrees. And then another one over here, which will be 360 minus 30. So 360 minus 30 is 330 degrees. So that'll be that last one. So these would be 3 angles, right, which have a reference angle of 30 degrees. Meaning, right, if I wanted to highlight it a little, these, right, angles right in here are each 30 degrees away from the x-axis. So you're always just measuring how far am I from the x-axis. You're ignoring any positives or negatives and just counting it as positive no matter what. And that is what we call the reference angle. Notice there's lots of other angles, right? Anything on that terminal side would also have a reference angle of 30. So instead of 150, I could add 360 to that and get, what would that be? 510 would be another angle over here. If I went all the way around and then back again, 510 would be also have a reference angle of 30 degrees. So that would be, there's lots, infinitely many, right, angles that have a reference angle of 30. Anything along those 4 lines that are highlighted in teal. All right, so I'm going to go through and just put in a few of these, how we would locate some of these angles. Then we'll come back and look at some trig, probably in the next video. So we'll actually start looking at some trig of these angles in the next video. But to wrap up here, I'm just going to highlight a few of these. I'm not going to do all 12 of these. But let's say we'll start with maybe this negative 105. Just say, where is that? So I may not know for sure, but there's 2 ways to count this. One way would be if you wanted to add, right, 360 to that. Negative 105 plus 360 would be, let's see, what is that going to be? 55, 255. So you could go around in the positive direction to 255, figure out where that ends, but really it'd be better if we could just figure out where's that negative going to take us, right? So negative 105, if you want to think about it, we'll go from, in this negative direction, negative 90 would take us right here, right, to this bottom part, and then an extra 15 degrees. So negative 105 would end like right here. So that would be the location for terminal side, right, going this way clockwise would give us that negative 105 degrees. So that is usually how I'll approach those negative angles, is just figure out how far I have to move, but go with the opposite direction that I would normally go in. Let's go and do a few more here. Let's try, so I'm going to erase some of this other stuff that's in there. Let's go and try this 175. Let's try that guy. So 175, right? This is almost to 180, right? But not quite. So we're going to go around, right? Almost to 180, but not quite. So terminal side would end somewhere in here. And I'd say that is my angle right there. So that would be 175 degrees, right, if I were in standard position. Now, it also says find the quadrant and reference angle for each of these. So we'll go ahead and do that and go back to maybe go back to that negative 105. So this reference angle, right, quadrant 2, so this is quadrants are going to start over here, top right, where everything's positive. X is positive, Y is positive. You spend a lot of time there, so that's quadrant 1. And then we'll follow our typical counterclockwise, right, motion. So quadrant 2, upper left, quadrant 3, lower right, or lower left, and then quadrant 4, lower right. So there's 1, 2, 3, and 4. A lot of times they'll put these in Roman numerals. It's not always required, but you'll see that often in the textbooks. Reference angle, right, for this one would be 5 degrees. We're 5 degrees short of that x-axis right there. So 180 minus the 175, that would be 5 degrees. The negative 105, right, when we did that one, let's go and put that one in. So that was, we said right here, right, we went 90 plus an extra like 15. So there's a couple ways you can find that reference angle, right? So this would be a quadrant 3 angle. You can say quadrant 3. Like I said, you can put the Roman numerals or just regular numbers. Either way is fine with me. But I'm just going to take, how far is that to that 180? Or we might even think of it as negative 180 since we're moving in the negative direction. So if I wanted to take negative 180 minus 105, right? Basically, that's going to be, how far is that? I need an extra, 75 degrees to get there. So we'll say 75 degrees between those. Now, you might get a negative, right, in between those. So I'm just mainly thinking of this as if they were positive, right? 180 and 105 would be 75 degrees for that reference angle, which is how far I have to get back to the x-axis. Another 75 degrees. Again, reference angles, always positive for these guys. Let's do just one more. Let's take, how about this 135, or I should say 1035 degree angle right here. Now this one you may not know where that is, right? Where in the world is that? It's hard to tell, but what you can do, right, is kind of break it down. So we'll take that 1035 and subtract 360, see what we get. So I get 675 degrees. 675. And let's subtract 360 again. So then I get 315. So this is basically going from, let's put in one more color here. Let's go and do black. How about? So we're going all the way around, right? Once for 360. Again, right, for another 360, and then again for 315, right? So 315 would end right around here, so I went just a little bit too far. So it's like 270 plus an extra 45, so we would end right about there. So we've gone around 360 twice plus that extra 315. The main thing you're looking at, right, is where you're ending, which is quadrant 4. So this is going to be quadrant 4. And the reference angle, right, we can actually think of that 315, right? How far is that from 360? Well, it's going to be, what, an extra 45 degrees away from 360. So 360 minus that 315 is going to be 45. So that reference angle right in there, right there to there, that's going to be 45 degrees. So as you go through, right, some of these, finding the reference angle, finding the quadrant, a lot of it will break down into, if it's a really big number like that 1035, break it down into something smaller and deal with that. The negative angles, you can always add 360, get it somewhere between the 0 and 360, and just try to find how far away am I from that x-axis. Next time we'll take a look at some additional pieces here, and kind of a overall like trig, right? Start defining these trig functions in terms of triangles we can draw in these different quadrants. So these different quadrants will have triangles in them that will draw to these terminal points, things like that. And so a lot of the angles that will end somewhere, we're just going to draw a triangle and then figure out from those sides what our trig functions are going to be. So that's kind of the importance of trying to figure out where all these angles going to lie, what are the reference angles, things like that. So we'll get to that in a couple extra videos. All right. Thanks for watching. We'll see you on the next one.